This is Dr. J. Mohan. I'm from EC department of Institute of Aeronautical Engineering. Today we discuss about the Laplace transform session 3 in the subject of signals and stochastic process. Today presentation outline is Laplace transform examples, property of Laplace transform in this, linearity property of Laplace transform, time scaling property of Laplace transform, frequency shifting property of Laplace transform reference. These are the topic I refer from signals, system and communication, BP Latti and AV Openum. For example of Laplace transform, first I should find the Laplace transform of f of t equal to e power minus at u of t. The Laplace transform of f of t, that is equal to Laplace transform of f of t is equal to f of s. This f of s equal to integration of minus infinity plus infinity f of t e power minus st dt together. So I received the signal is u of t. That's why we know u of t is equal to 1 when t is greater than or equal to 0, 0 otherwise. So this means 0 to plus infinity, the values represent as a 1, then less than of 0 less than of infinity is represented as a 0. So here I should draw the waveform. So this is 0, this is t, it's go for up to infinity, then 0 to plus infinity, all it's represented as a 1. So remaining portion less than of t, that is minus of t condition, up to minus infinity, all it's represented as 0. That's the meaning. This means the interval it will be started for the 0 to plus infinity. That's why I should write for the equation is 0 to, that is Laplace transform of e power minus at is equal to integration of 0 to infinity e power minus st dot e power minus at dt. This we received. So due to this u of t, I make to write as a 0 to infinity only. So then after this term e power minus st e power minus at, it will be have similar, then I represent as a integration of 0 to infinity e power minus t s plus a dt. If we do differentiation for this one, e power minus, that is e power minus t s t divided by minus of, here is minus, this minus only came for here, s plus of a, then we should substitute for the infinity's first term, that is equal to e power, I take it out for the minus of 1 by s plus of a, e power of minus infinity minus of e power 0, the next term is 0. So now e power infinity is equal to 0, e minus of e power 0 is equal to minus 1. So this minus and this minus getting to cancel, remaining term is represented as 1 by s plus of a. Now the Laplace transform of e power minus at u of t is equal to 1 by s plus of a. So next example I should take for the find the Laplace transform of e power plus at u of t. As usual, the u of t we know is going to represent as a 1. It's to the t is 0 to infinity it will be have, and 0, that is t is represented as a 0 to minus infinity. So these two terms we are going to take to that. Now 0 to, we need to go for the Laplace transform. Laplace transform of f to t equal to integration of 0 to infinity e power minus st f of t dt. So here I wrote for the unidirectional condition. Now already you have the u of t, that's why the integration is present for the 0 to infinity only. the Laplace transform of e power minus plus at, integration of 0 to infinity e power minus st e power at dt we write. Then we need to simplify for this two term. I write as a integration of 0 to infinity e power minus s minus f a dt. Then this value we make to differentiate for this term. We got for the minus of e power minus s minus of a divided by s minus of a. In terms of e power is t. Substitute for the limit 0 on the infinity. What is that? Minus 1 by s plus s minus of a e power minus infinity minus of e power 0. Then after simplification we got for the 1 by s minus of a. The Laplace transform of e power at is equal to 1 by s minus of e. Okay. See last sum, the f of t is taken for the e power of minus at u of t. We got f of s equal to 1 by s plus of a. Now we taken for the f of t, this sum e power plus at u of t, we taken for the Laplace transform, that is equal to f of s. This is Laplace transform. Laplace transform is equal to 1 by s minus of a. See, if changes happen for the sign, then the output sign also getting to changed. Here is plus, that's why it will be a minus. Here is minus, it's represented as a plus. Okay. Next example. Find the Laplace transform of f of t cos at u of t. Now we follow for the same procedure. The Laplace transform of cos at u of t is equal to 0 to infinity. U of t in the sense that is 0 to infinity. The value is equal to 1. Remaining portion is represented as 0. E power minus st cos at dt. As a formula, what will be represent? Integration, that is f of s. This is equal to f of t. That is a Laplace transform of t. Here, not for f, Laplace transform of t is equal to f of s. Integration of minus plus into f of t e power minus st we write. Okay. So this f of t is called for the cos at. The limit is we taken for the u of t into 1. So that's why I write as a integration of 0 to infinity e power minus st cos at dt we wrote. So now e power st. Okay. E power st. At the same time, we have the at. That formula I should write integration of e power ax sin bx dx is represented as e power ax divided by a square plus b square, a sin bx minus b cos bx we write. So we use for this term, this case, as well as a cos term, integration of e power ax cos bx dx equal to e power ax divided by a square plus b square, a cos bx plus b sin bx we wrote. Okay, I use for this equation for here. So here is e power a st sir, I keep here s square plus a square minus of s. Okay, that is a is equal to minus s cos b, that is ax plus a sin ax. Then we need to substitute for the 0 to infinity as a limit. Then this infinity term is represented as 0. Then we can substitute for the 0 term. What we are going to, this term only is going to happen. Remaining all it's represented as 0. 0 in the sense this is 1. So that's why minus of 1 by s square plus a square minus of s right equal to s divided by s square plus a square. Then if we take for the Laplace transform of cos a t is equal to s divided by s square plus s square. Next, find the Laplace transform of sin at u of t. So now I take for the Laplace transform of sin at is equal to integration of 0 to infinity e power st sin at dt we write. Okay, here we use for this formula. Okay, previously we use for this formula. Now the term is cos, that's why we use for this one. Now if the term is sin, that's why I use for this formula of integration case. So that is equal to e power minus st divided by s square plus a square minus of s sin at minus a cos at integration. That will be limit integration will be 0 to infinity. We substitute. Finally, we got Laplace transform of sin at is equal to a divided by s square plus a square we got. Okay. Now I should write for here Laplace transform of cos at. Okay. Then Laplace transform of sin at. Okay. These two terms, if cos in the sense, it will be have for the s divided by s square plus a square. So this is a divided by s square plus a square we wrote. Okay. So now we know this term whenever we take for the Laplace transform of cos at and sin at, we know the formula. Cos at Laplace transform is equal to s divided by s square plus a square, and sin at Laplace transform is represented a divided by s square plus a square. Next, we go for the cos h at. The cos h at is represented as e power at plus e power minus at divided by 2. So this is equal to cos h at. Okay. So the cos h at of Laplace transform equal to 1 by 2 Laplace transform of e power at plus e power minus at. I apply for this formula for Laplace transform. So 1 by 2, the Laplace transform, here I make to write. So the Laplace transform of 1 by 2, I should write for here integration of 0 to infinity. Then this term e power minus st e power of at. Okay, dt plus integration of 0 to infinity e power minus st e power of at dt, that is minus at dt I wrote. So this is 1 by 2. I should write 0 to infinity e power of minus, I take it out, s plus s minus of a into t, s minus of a into t dt plus integration of 0 to infinity e power minus, I take it out, s plus of a t dt we wrote here. Okay. So now this term, this 1 by 2 is common for both. So this term Laplace transform of integration is equal to 1 by s minus of a. For this term is represented 1 by s plus of a. This is we studied for the last problem. Okay. So now I should write for the 1 by 2 is common. Here 1 by s minus of a plus 1 by s plus of a. So this is I do for the cross multiplication as well as of this multiplication I make today. So now this a and this a cancelled. 2 time of case. 2 time. This 2 here is 2 time of s is this 2 is cancelled. So finally we got s divided by s square plus s square minus a square. The Laplace transform of h of at is equal to s divided by s square minus of a square we got. Same like that one, we go for the cos h at u of t Laplace transform. Find the Laplace transform of f of t is equal to sin h at u of t. So sin h at equal to e power of at minus of e power of minus at divided by 2. Okay. As per the Laplace transform of this term is equal to Laplace transform of this term. Then I write for the this here Laplace transform of e power minus at. This is one case. Minus of, I take it out for the 1 by 2. Laplace transform of e power minus at. Okay. So the 1 by 2, the Laplace transform of case of e power at is equal to minus, that is, this is represented as u of t. That's why limit is going to happen for the 0. Okay. then e power at e power minus st minus of, sorry, dt, dt minus, this is one term. Another term, integration of 0 to infinity e power minus at e power minus st, sorry, this is plus, here also plus. Okay, so dt we wrote. So now I write as a 1 by 2 integration of 0 to infinity e power of, I take it out minus here, s minus of a t dt plus minus of integration of 0 to infinity e power minus of s plus of a t dt we wrote. So the Laplace transform of this two term I should write here is 1 by s minus of a. Then this term is represented say 1 by s plus of a. So see 1 by 2 I take it out. The first term 1 by s minus of a plus 1 by s plus of a. Just make to do for the cross multiplication and multiply these two. So this case what will be happen? This s and this s cancel. We got for the 2 time of a. This a, there's two is getting to cancel. Finally we got for the a divided by s square minus of a square. The Laplace transform of sin h at is equal to a s square minus of a square. Next, find the Laplace transform of t power n u of n. The Laplace transform of t power n is equal to integration of 0 to infinity u of n is there. That's why I make to write for this result. E power minus st t power n d of n. Okay. Before we go for the Laplace transform condition, the Laplace transform of t power n equal to n divided by s l of t n minus 1. If how shifted for the one version Laplace transform of n minus 1. So this term is represented say n minus 1 divided by s l t power n minus 2. This one it will be going to continue together. Now based on this case I take for the t power 3 Laplace transform of t power 3 equal to 3 by s Laplace transform of t square. This Laplace transform of t square is equal to 2 by s Laplace transform. The Laplace transform, finally I concluded Laplace transform of t power n, this value is equal to n factorial divided by s power n plus of 1 or terms of n plus 1 divided by s n plus of 1 I write. Now the Laplace transform of any signal, that is s 1 by s square. Laplace transform of t square equal to 2 factorial divided by s power 3. Laplace transform of 3 is equal to 3 divided by s power 4. Okay. So now we should adapt these terms to here. So this is equal to t power n e power minus st divided by minus of s limit 0 to infinity minus of integration of 0 to infinity n t power n e power minus st divided by minus s dt. Then if we substitute for this two both the term, it's getting to 0. Okay, this is because of here are the t power n. Here we have the infinity in the sense 0. Then t power infinity will be 0. Then 0 will be how the, this is 1, this is 0. So that means finally we got this term only is going to present. Then I take it out for the n divided by s. This minus minus getting to cancel. N divided by s integration 0 to infinity e power minus st t power n minus of t dt. So this is this term I represent as a n by s Laplace transform of t power n minus of 1. So finally I concluded that t power Laplace transform of t power n equal to n by s n minus 1 divided by s n minus 2 divided by s up to till we have the 1. Okay. So this term I should write n factorial divided by s power n Laplace transform of 1. Here Laplace transform of 1 is represented as a 1 by s. Okay, Laplace transform of that, this is studied for the last session. The Laplace transform of x of t is equal to 1. The Laplace transform of x of s equal to 1 by s we find. So now we that value I am adapted for here. So this term is represented as a n factorial divided by s power n. So now finally the Laplace transform of t power n is equal to n factorial s power n 1 by s. That is Laplace transform of t power n is equal to n factorial divided by s power n 1 by s. We wrote. Okay. So next is find the Laplace transform of sine square t. Yeah, you know the sine square a is equal to 1 minus of cos 2a divided by 2, and cos square a is equal to 1 plus of cos 2a divided by 2 we know. So the sine term of Laplace transform, I should substitute this formula 1 minus of 2a divided by 2. Laplace transform of 1 minus of cos 2t divided by 2. That divided by 2 is a constant, then we take it out 1 by 2 Laplace transform 1 minus of cos 2t 1 by 2. This term Laplace transform, this term I should write as a 1 by 2 Laplace transform of 1 minus of Laplace transform of cos 2t. Okay, we write. So this term is represented as a 1 by s. We know. So we know cos 2 omega. We studied further here. What is it? Cos at. Okay, we studied s divided by s square plus a square. For in that equation we using for here cos 2t. Then a is equal to 2. So 1 by s. Okay, this is equal to a equal to 2. So this means I use for the cos at u of t. This value is equal to s divided by s square plus a square. Okay, in the term of a, here using for the 2. So that's why what I am writing s divided by s square plus of 4. The a is a equal to 2. So we substitute here got for this one. Finally, I make to write the Laplace transform of cos sine square t is equal to 1 by 2 1 by s minus of s divided by s square plus 4. Okay. Then same like that one, we go for the cos cube t. So cos cube t is represented as we know the cos 3a equal to 4 cos cube a minus 3 cos a. So cos cube, this is we find for the cos cube is equal to 3 by 4 cos a plus 1 by 4 cos 3a we wrote. Okay, this formula we may adapt it for here. We do for the Laplace transform. This means you take for this one Laplace transform of 3 cos t. This 3 is constant. You take it out for the 3 outside cos t plus Laplace transform of cos 3t. Okay, this is cos t is represented as here s divided by s plus of 1. Here a is equal to 1. Okay, here a equal to 3. So this term it will be represented as here 3 s divided by s square plus a square is equal to 3 square 9. You should substitute here. Then if possible you can simplify. This is represented as cos cube t Laplace transform. Okay. Next we go for the property of Laplace transform. Okay. It's around other 12 properties are there. This session we will see for only 3 property with some example. Linear property of Laplace transform. The first property is represented as a linear property of Laplace transform. The statement linear property of Laplace transform state that the Laplace transform of a weighted sum of the two signal is equal to weighted sum of individual some Laplace transform. Otherwise, we said the Laplace transform is going to satisfy for the superposition principle and homogeneous solution. Then the Laplace transform is going to satisfy for the linear property. Okay, whether we can go for this statement, otherwise we go for the another statement like it's going to satisfy for Laplace transform is going to satisfy for superposition principle and homogeneity principle. Now, I need to prove for the linear property of Laplace transform. I should take for the two input. One is x1 of t, another one is represented as x2 of t. x1 of t and x2 of t. So x1 of t Laplace transform is equal to capital letter x1 of s and x2 of t Laplace transform equal to capital letter x2 of s. Okay, according to the linear property statement, a x1 of t plus b x2 of t take Laplace transform a capital letter x1 of s plus b capital letter x2 of s. Okay, so now we need to prove, then we take for the definition of Laplace transform. The definition of Laplace transform is represented as a Laplace transform of x of t equal to x of s equal to integration of minus infinity x of t e power minus st dt we wrote. Okay, so then Laplace transform of a x1 of t plus b x2 of t is equal to integration of, we write for that formula. So see what is it? Laplace transform of x of t equal to x of s. This is equal to integration of minus into to plus into x of t e power minus st dt we wrote. Yeah, so this x of t term I write for the a x1 of t plus b x2 of t. So here I write for here a x1 of t plus b x2 of t e power st dt. This term it will be have similar. Okay, now this case we make to this integration will be going to distributed for the all the part, because of every part have the x of t term. So first I write as a integration of 0 to infinity x1 of t e power minus st dt plus b integration of 0 to infinity x2 of t e power minus st dt we write. The Laplace transform of a x1 of t plus b x2 of t is equal to a. This term I represent for the x1 of s. This term I should write for the x2 of s. Okay, you know that formula based on that one. So a x1 of s plus b x2 of s. Now it will be going to satisfy for the statement. The statement state that Laplace transform of weighted sum of the two signal is equal to weighted sum of the individual sum Laplace transform. See, Laplace transform of weighted sum of the two signal is equal to Laplace transform of the weighted sum of the two individual signal. Okay, this is one, this is another one. So it can also represent as, I write here, a x1 of t plus b x2 of t Laplace transform of a x1 of s plus b x2 of s. For example, using the linear property, determine the Laplace transform of the function is given by x of t equal to 2 e power minus 5t u of t minus 15 e power 4t u of minus t. Now this two signal I consider as a, this is one signal. This whole signal considers two cases. This is x1 of t. This is I consider as x2 of t. I wrote here x1 of t is equal to x of t is equal to x1 of t plus x2 of t. Now x1 of t is equal to 2 e power minus 5t u of t. x2 of t I take for the minus 15 e power 4t u of minus t. Okay. By definition of Laplace transform, the Laplace transform of x1 of t is equal to Laplace transform of this x1 of t, we should substitute Laplace transform of 2 e power minus 5t ut. That is 2 is constant, take it out. Remaining portion is how the e power minus 5t u of t. This term is represented as here. I write for here that 2 integration of 0 to infinity x of t is e power minus 5t e power minus st dt. Okay, so this one I should make as a 2 integration of 0 to infinity minus, I take it out, s plus of 5t dt. So you take for this one, the Laplace transform is represented as a e power of, that is 2, I write minus s plus of 5t, here is minus, divided by s plus of 5. The substitute the limit 0 to infinity. The infinity term is represented as 0. Then I write as a 2 minus 2. This minus is came here. So 0, this side is e power infinity. minus of e power 0. That's it, divided by s plus of pi. So this term is represented as a 0. This term is represented as a 1. Okay. Here is minus 1. This minus and this minus are getting to cancel. Finally, 2 divided by s plus of pi. I wrote here 2 by s plus of pi. The ROC, region of conversion, always go for the minus of right direction. Next case, x2 of t. We need to go Laplace transform of x2 of t is equal to Laplace transform of minus 15 e power 4t u of minus t. So the minus 15 we take it Laplace transform of e power 4t u of minus t. So here is minus. That's why the term also be going to get to the minus. Okay. So minus 15 divided by minus of s plus of s minus of r. These two minus are getting to cancel. Finally, I make to merged for both the case as per the linear property principle. The true, that is Laplace transform of x1 of t, then minus of Laplace transform of x2 of t. We wrote. Then both value, what you are finding the value, you can substitute and simplify. Finally, we got for the output is 17s minus of 83 divided by s square plus s minus of 20. Then I wrote for the Laplace transform at finally the case of linear property. 2 e power minus 5t u of t minus 15 e power 40 u of minus t Laplace transform equal to 17s minus of 83 divided by s square plus s minus of 20. The ROC is present for the minus 5 to plus 4. Next, time scaling property of Laplace transform. The time scaling property of Laplace transform state that x of t tends to Laplace transform of x of s, then x of a t Laplace transform equal to 1 by mod of a x of s divided by a. If multiply with any constant, real constant in the time domain of input side, the output of Laplace transform in the system is represented as 1 by mod of a x of s by a. We need to prove for this statement. You take for the definition of definition of Laplace transform. The Laplace transform of x of t is equal to x of s. Here I write Laplace transform of x of t is equal to x of s. This x of s equal to integration of minus into plus b x of t e power minus st dt we write. So that term I write here. Now I consider as a t equal to at. That means t tends to at. Laplace transform of x of at is equal to integration of 0 to infinity x of at e power minus st dt. Now at I take for the p in the right side. Then t is equal to p by a at dt is equal to 1 by a dp. So those value I should substitute for the this equation. Okay. Those value I substitute for the right side of the equation. Then I represent for the integration of 0 to infinity xp e power minus s divided by a p of dp by da. We write. So this case Laplace transform of x of at is equal to 1 by a integration of 0 to infinity xp of e power minus s divided by a p dp. So now the previous case of Laplace transform, the equation what we are writing, Laplace transform of x of t, Laplace transform of x of t is equal to x of s. The x of s equal to integration of minus plus t x of t e power minus st dt we write. Here s is there, that's why we make to do for the s. But if you have in the place insist of s, it will be going to present by s by a. That's why I write as a x of s by a to here. See, x of s by a. What the term is present for the s term, then we write it. That is what the remaining portion we have the 1 by a, we take it out for the 1 by a. This expression of Laplace transform is valid for all value of a. That is all value of factor of a. Then Laplace transform of x of at is equal to 1 by mod of a x of s divided by a. So then I modify for your equation x of at is equal to, that is Laplace transform 1 by mod of a x of s divided by. The time scaling property was proved in the Laplace transform. Next property, frequency shifting property of Laplace transform. The frequency shifting property of Laplace transform state that multiplication by the complex exponential value. I multiply with the complex exponential value in a shift of a in S domain. In the time domain, if you are going to multiply with the e power at, the S domain is going to shifting for the a duration. Okay. So now we take for the Laplace transform of x of t is equal to x of s. According to the frequency shifting property, we multiply with the input of e power at. We have said x of t. The Laplace transform we take the shifted version. Okay. The shifted version of x of s plus of a. Here is minus is there, that's a replace. If you are plus, here we got minus. This is called for the time shifting, that is a time based frequency shifting property of Laplace transform. We need to prove for this one. So I take for the Laplace transform of x of t equal to integration from 0 to infinity x of t e power minus st dt, because all we are going to dealing with unidirectional. Now x of, that is instead of x of t, I should substitute e power minus at x of t here. So this to put on, I substitute for the integration from 0 to infinity e power minus at x of t e power minus st dt I wrote. Now we need to simplify for this equation. So we know that x of t is that, see here, I simplified for 0 to infinity x of t e power of, I take it out for the minus s plus of a t dt is that. You know the Laplace transform of x of t e power minus s plus a t into dt, then we write as a x of s plus of a. Okay, so it can also write as e power at x of t is equal to Laplace transform of x of s plus of a. If the function x of t is multiplied by the complex exponential value of e power at, then its produced output is represented as a x of s minus of a. I should write here both Laplace transform of the time signal multiplied with e of at in the term of x of t in the input. The output is represented as a x of s plus of a. But Laplace transform of e power at plus at x of t, then this is x of s minus of a. We got both the term we studied. Next case, we go and solve some problem based on this two property. Find the Laplace transform of the function x of t is equal to e power minus 60 sine 20 at u of t by using properties of Laplace transform. Okay, so we know the Laplace transform of sine at u of t is equal to a divided by s square plus a square. For the given equation is, I should wrote x of t equal to e power minus 60 sine 20 at u of t. Using the time scaling property, x of at is equal to 1 by a x of s divided by a of Laplace transform. See here, the Laplace transform of 20 at u of t is equal to 1 by, here 20 is there, time it will be going to be 1 by 20 Laplace transform of sine at u of t I write 1 by 20 a divided by s divided by 20 whole square plus a square we wrote for this equation. Now Laplace transform of 20 at u of t is equal to 20a divided by s square plus 20a whole square. By using the frequency shifting property, we should multiply with the e power minus at x of t. Laplace transform is equal to x of s plus of a of Laplace transform. Now Laplace transform of e power 6, that is minus 6t sine 20 at u of t is equal to 20a divided by s square plus 20a square. Now s tends to s plus of 6. Just you can substitute for here 20a divided by s plus of 6 whole square divided by that is 20a divided by s plus sub 6 whole square plus 20a square. Okay, so those topic I referred from signals and system and communication for B Latik and B Wagner for signals and system. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.